Deep beneath the surface of Geneva, something truly extraordinary, yet potentially dangerous, sits. The Large Hadron Collider (LHC). This enormous machine is a marvel of modern science, capable of peering into the tiniest parts of the universe and already credited with helping researchers discover groundbreaking ideas like the Higgs boson. Often referred to as the God particle, the Higgs boson was a significant find, filling in gaps in our understanding of how the universe operates. But as exciting as this achievement is, there are concerns about what we might be unlocking in the pursuit of knowledge. According to physicist Brian Cox, something secretive has been discovered at CERN, sparking both curiosity and fear. Is it possible that we are taking a risky road, probing realms we don't fully understand? Before we delve into these worries, let's first look at what the LHC is and how it works. CERN runs the LHC, a massive 17-mile ring of magnets that forms the largest and most powerful particle accelerator in existence. Its size and capabilities are mind-blowing, enabling researchers to recreate the same energy conditions as those that existed when the universe began. By smashing protons together at incredibly high speeds, the LHC mimics the conditions of the Big Bang, allowing researchers to probe the fundamental building blocks of the cosmos. With temperatures soaring millions of times hotter than the Sun, and cooling systems keeping components colder than space, the LHC achieves feats that once seemed impossible. Its intricate setup is a testament to human ingenuity. Inside, there are over 1,200 magnets guiding the protons and another 392 focus magnets directing them to their collision points. To hit particles with the required precision, comparable to trying to collide two needles from 6 miles apart, requires an astonishing level of accuracy and technology. The accelerator is buried underground, shielding the world from harmful radiation, and maintained at a chilling temperature of -460 degrees Fahrenheit. As the particles crash into each other, detectors like ATLAS, CMS, ALICE, and LHCb record the data, capturing crucial insights into the nature of matter and the universe itself. The Higgs boson, for instance, could help us understand how mass is distributed across the universe, offering a glimpse into the very structure of everything around us. Even though the Large Hadron Collider is an amazing tool for deciphering the mysteries of the universe, its enormous power raises some troubling questions. As we peer deeper into the unknown, we must ask, are we prepared for what we might find? Could we be inadvertently unlocking forces we don't fully comprehend? Some have raised the concern that, in our attempts to mimic the Big Bang, we might be opening a Pandora's box of unforeseen consequences. Recent comments by Brian Cox have intensified these worries. He explained that by recreating the extreme conditions of the early universe, the LHC could lead to unexpected, even dangerous, results. The collider, after all, doesn't just explore the Higgs boson and other known particles. It also delves into dark matter, which accounts for a large portion of the universe's unseen mass. But dark matter, as the name suggests, remains elusive, its properties and composition still a mystery. The LHC could be our best chance at unraveling its secrets, but this could also bring unforeseen risks. The collider's extreme conditions, akin to those that existed at the very birth of the universe, come with dangers that must not be ignored. Scientists have even speculated that the collider could inadvertently create tiny black holes, fears fueled by the potential of quantum physics to warp space and time. Stephen Hawking, a renowned physicist, expressed concern that high-energy LHC experiments could result in vacuum decay, a catastrophic event that could destabilize space and time itself, with repercussions as severe as the demise of Earth. Sir Martin Rees, a leading cosmologist, echoed these concerns, suggesting that such instability in the vacuum could have disastrous effects. CERN, of course, insists that any black holes created by the LHC would be short-lived and harmless. Still, the notion that we might accidentally create something as dangerous as a black hole, even a minuscule one, has made the scientific community more cautious. Despite these warnings, it's essential to acknowledge that the risks, while real, are incredibly low. To reduce these risks, safety procedures have been established by CERN. However, no amount of preparation can completely eliminate the inherent uncertainty of pushing the boundaries of scientific exploration. As we delve deeper into the fabric of reality, we must weigh the potential risks against the knowledge we hope to gain. The LHC is a tool of immense power, one that is as much about the human drive for discovery as it is about scientific progress. It demonstrates our relentless desire to understand the cosmos, but it also highlights the responsibility that comes with such power. Beyond the existential risks, the LHC's effects reach into various realms of knowledge and technology. With over 10,000 scientists, engineers, and technicians working on this colossal project, the collaboration spans the globe. The data generated by the LHC is so vast that it has revolutionized computing, requiring new methods of data storage and analysis. But the implications of the LHC go far beyond particle physics. The research conducted at CERN has far-reaching effects on fields such as medicine, material science, and environmental studies. For example, understanding the Higgs boson better could lead to the development of entirely new materials or technologies. Similarly, the LHC's work on dark matter may one day uncover hidden aspects of the universe, fundamentally changing our understanding of space, time, and physics itself. At the same time, the LHC's work with concepts like supersymmetry and extra dimensions could radically reshape our comprehension of the fundamental forces of nature. Supersymmetry, a theory that links two types of particles, bosons and fermions, predicts the existence of superpartners that have yet to be discovered. Should the LHC find evidence of these particles, it could offer a new framework for understanding the universe. The LHC's research also has profound implications for the future of computing, especially in the realm of quantum computing. By revealing how particles interact at a quantum level, the LHC is paving the way for technologies that could one day revolutionize how we process information. Yet, as we stand on the brink of these monumental discoveries, we must also confront the ethical questions that arise. While the pursuit of knowledge is thrilling, it comes with a responsibility to ensure that this newfound understanding is used wisely. The potential applications of LHC research are vast, but so are the risks. From developing advanced weapons to creating technologies we cannot control, the possibilities are both exhilarating and terrifying. This raises an important ethical dilemma. How do we ensure that these discoveries are used for the benefit of humanity and not to cause harm? Global cooperation and transparency are key to addressing this challenge, ensuring that the knowledge gained through the LHC is shared and utilized responsibly. The LHC also raises significant concerns about the environmental impact of such powerful technology. With its enormous energy requirements, the LHC places a considerable strain on resources and ecosystems. While CERN has made efforts to reduce its carbon footprint by relying on renewable energy and improving efficiency, the environmental consequences of such large-scale scientific endeavors cannot be ignored. This underscores the need for sustainable practices in science, particularly as we continue to explore the frontiers of knowledge. As the LHC continues to unravel the mysteries of the universe, it serves as a reminder of both the power and potential dangers that come with humanity's drive for knowledge. It's not just about breakthroughs in physics or understanding dark matter. It's about exploring the very building blocks of existence, and what happens when we try to manipulate them. With each experiment, each collision, scientists push the limits of our understanding. Yet we must also be mindful of the profound. As we continue this journey of discovery, the LHC becomes not just a tool of scientific advancement, but a symbol of the complexities and ethical dilemmas we face in our quest for greater understanding. The knowledge it provides has the potential to reshape our view of the universe, but it also forces us to ask critical questions about the consequences of such knowledge. How do we responsibly harness this power? How do we ensure that the discoveries made at the LHC are used for the betterment of all, and not for destructive or selfish purposes? There is a fundamental tension between the excitement of discovery and the uncertainty of the unknown. Each new breakthrough brings with it new possibilities, but also new risks. With each proton collision at the LHC, we uncover more about the fundamental forces of nature, the origins of the universe, and the nature of dark matter. Yet we are also confronted with the possibility that the very act of investigating these mysteries could lead to unforeseen consequences. The creation of miniature black holes, the destabilization of the vacuum of space, or the development of technologies that could be misused. All of these are potential outcomes we cannot fully predict or control. The reality is that the LHC, and the field of particle physics as a whole, is at the frontier of human knowledge. We are peering into the deepest recesses of the universe, asking questions never asked before, and attempting to understand forces and phenomena once thought beyond human comprehension. In this pursuit, we are venturing into a realm where the boundaries between science, philosophy, and ethics blur. It's no longer just about understanding the mechanics of the universe. It's about grappling with the responsibility that comes with this newfound knowledge. What makes this journey even more challenging is that science often moves faster than society can keep up. The advancements made at CERN could lead to groundbreaking discoveries in fields like quantum computing, material science, and medicine. However, they also carry the potential for unintended consequences, both in terms of the physical risks associated with the experiments themselves and the ethical implications of how the knowledge is applied. How do we ensure that the discoveries made at the LHC are used in ways that benefit humanity as a whole, rather than being exploited for profit, power, or destruction? This brings us to the question of governance and regulation. The LHC is an international endeavor, and its potential impact spans the globe. As such, it requires a level of global cooperation and accountability never seen before. How do we ensure that countries with different values, priorities, and concerns work together to manage the risks and rewards of such powerful technology? The LHC is not just a scientific project, it's a global one, and its implications reach far beyond the walls of CERN. Decisions made here could affect the future of our planet, our understanding of reality, and the course of human history itself. The importance of transparency, ethical oversight, and global cooperation cannot be overstated. We must engage in open and honest discussions about the potential risks and benefits of the LHC's experiments. The scientific community, policymakers, and the public must work together to ensure that the pursuit of knowledge is balanced with a duty to protect our world and future generations. As we push the boundaries of what is possible, we must also take responsibility for the potential consequences, both the known and the unknown. And then there's the environmental impact. The LHC's immense energy requirements and its role in the consumption of global resources highlight the need for sustainability in science. The pursuit of knowledge should not come at the expense of our planet's well-being. The scientific community must strive to minimize its ecological footprint and ensure that future generations inherit a world that can sustain their own discoveries and innovations. This balancing act between progress and preservation is a delicate one, but it is essential if we are to move forward responsibly. As we look to the future, the LHC stands as a testament to humanity's unyielding desire to explore, understand, and innovate. But with this incredible tool comes an equally incredible responsibility. The search for the unknown is both thrilling and dangerous. It is a journey that requires humility, caution, and foresight. As we unlock the secrets of the universe, we must remain vigilant, ever mindful of the risks and the profound ethical questions that accompany such powerful knowledge. In the end, the Large Hadron Collider is more than just a scientific instrument. It is a reflection of our collective aspirations and anxieties. It is a reminder that while knowledge has the power to transform our world, it also carries with it the potential to reshape our very existence in ways we may not yet fully understand. As we continue to push forward in our search for answers, we must do so with a deep sense of responsibility, ensuring that the discoveries we make serve to benefit all of humanity, not just the few.